it's important. It's important that you understand how to write your vertical component and your horizontal component. Please pay attention on this, okay?
Yes, sir.
Now, if you see this point, the starting point, maybe we should do it with what is this? Different marker. So now, if the force is pulled, the horizontal component will move away from that starting point. It will point in that direction, and we're going to call this F.
X.
Yeah, exactly. Let's call it Fx. It's going to point in a different direction. You're going to see why it's important for you to differentiate this thing. So now, then we're going to have a vertical component. It will start here. It will go up to that arrow and point head to head with the applied force. This will be your Fy. Are you with me on that?
Yes.
So now, my question, you asked me a question, why the vertical force? Why it's Fy reducing the normal force? Let me explain. Let's draw the free body diagram. When we draw the free body diagram, we need to list all the vertical forces. How many are they?
Okay.
Pay attention.
There are 3.
Exactly. So how many are going up? 2.
2, yes.
Which is the Fn and what else? Fy. Then where are the Fg going? Where is Fg going? Down.
Bottom, yes.
Exactly. So now from this information we can see that if we add this thing, remember F net, we're going to add all the forces and subtract all. Okay, let's choose direction. Let's say this is up as positive. So all the forces that are going up are positive, which is Fn. We add it with Fy. Therefore, we minus all the forces that are going down and equate this to 0.
0.
Let's calculate the normal force. Fn is equals to, the Fg goes to the other side to be positive. Can you see that?
Yes.
Then minus the Fy. You understand how we got the normal force?
Yes, I understand.
Let's go back to that statement. We said that when a mass is pulled at an angle, the force has what? A horizontal and a vertical component.
Yes.
And the vertical component
will
reduce the force pulling the ground. So the vertical component we are subtracting from Fg, so it reduces the force that is pulling into the ground. And what happens? It reduces the normal force. If you still remember on the previous, we said the normal force is mg, but now we are subtracting Fy from Fg. The normal force will decrease.
Okay, now it makes sense.
100%.
Okay.
So can you see that the free body diagram gave you an answer that you were looking for?
Yes.
Please.
Yeah.
This is why you'll be like, that Newton's law, I got it right. But when the marks comes back, you are surprised, because the normal force plays an important role in calculation. Listen, I don't want you to go all the trouble. Just check. Ask yourself, is the force pulled at an angle? If the answer is yes, your normal force will be, remember Fg is just what? Fg is just
M times G.
Exactly. Minus. Let's talk about Fy. So Fy, I'm just gonna for now say Fy, it will be Fa, the sine of theta. I'm going to explain where is that coming from.
Yes.
But now, this is the formula to memorize. You understand?
Oh, okay.
If the force is pulled at an angle, the normal force is equal to mg minus Fa sine theta.
Okay.
Are you happy with that?
Yes, sir.
So now, to calculate the normal force of this object. It will be mg minus Fa, the sine of theta. Let's substitute. The mass was given as 10, g is 9.8, minus the applied force is given as 100, and the sine of that
30.
theta, which is 30. You just have to punch everything on the calculator and tell me what you get.
Sine 30. It gives me 930.
You made a very big mistake somewhere. Did you say 10? It's very important to be careful when you punch in your calculator.
Oh,
Okay?
no, sorry, sir. I said 98. It's 48, sorry.
48 what?
Yes.
Newtons.
Newtons.
Exactly.
Sorry.
Please don't forget the SI unit. 48 Newton. This is how we calculate the normal force if the force is pulled at an angle. You understand?
Okay.
Listen. Now let's explain this part. Where is the FA sine theta coming from? I'm not sure. You know where is that coming from?
Yes, I do.
Okay, exactly. But now let's explain. Remember, this is 90 degrees, né?
Yes, sir.
So let's write down the triangle here. This is my F applied. This is my Fx. And this is my what? This is my Fy. So
Yes.
what I'm going to do is that I'm looking for what? I'm looking for Fy, and I have Fa. So I have opposite and hypotenuse. Okay?
Yeah.
So if I use the SOHCAHTOA, now we're going to maths. The SOHCAHTOA tells us that the sine, we have the opposite and the hypotenuse. So we look for O and H. This is the trig ratio that we need to use, which is the sine of theta is equal to opposite over hypotenuse. And the opposite is equals to Fy over Fa. So what we are trying to say is that we have the sine of theta that is equal to Fy over Fa. The aim here is to do what? The aim is to make Fy subject of the formula. So let's cross multiply both sides by Fa, both sides by Fa. Therefore, what is Fy equals to? Fy is equals to Fa, the sine of theta.
Yes.
So now it's very important that we memorize this so that we can save time in an exam. In an exam, we just have to know that this is the formula that we use to calculate what? This is the formula that we use to calculate the normal force.
Okay, sir.
Are you happy with that?
Very happy, sir.
100%.
100%.
Nice. Because now, my question is that, remember the force now is pulled at an angle. Can you see? Because of the arrow.
Yes.
I have a lot of questions now. What about this object? Let's say now the force is pulled at an angle. What will be the formula to use for normal force? We're going to talk about that. You understand?
Okay.
But before we do, tell me, do you have any question based on this one?
No, so the only question that I had was why would the vertical force of Y reduce the Fn and Fj, but now I got it.
Exactly.
Yeah.
So it's best that you understand everything, because this is how I summarize Newton's law. You'll see, after this example, we are moving to an inclined. We're going to take this object, put it on inclined. Then if you understand that part, you'll see, you're going to master Newton's law. You're going to get that 22 marks in question 2.
I'm
But
going to get it.
100%, you'll see. But for now, this is where we're going to stop for this one. Let's go and work